AI is definitely the word of 2024, and it's finding its way into every nook and cranny of our lives, from hijacking the Pope's wardrobe and Drake's vocal cords, to mastering protein folding and developing new cancer treatments. One area it's not yet gone fully mainstream is 3D model generation. However, whilst you can't yet just throw up ChatGPT and request a 3D printable model of Will Smith eating spaghetti, there are a number of innovations already out there which create 3D printable designs using AI. I've been testing and experimenting with a number of these more interesting 3D AIs, and in this video I'm going to be going through what each of them does and how they perform when paired with 3D printing. So let's have a look. There's several techniques, technologies and platforms that I'll be looking at here, but everything I cover in this video is currently available to use for free, either in its entirety or at least on a trial basis. Some use AI to generate 3D models from scratch, and some use AI to create 3D models of real-world objects without the need of a 3D scanner or photogrammetry. The first one I'd like to talk about is a pairing that I've been experimenting with for a while. LLMs, or large language models such as ChatGPT, Claude and Copilot, have been a key part of the growth of mainstream AI over the last year or two. Large language models are exactly that. They are focused on language, and most can't interpret other mediums such as images or audio on their own, though many LLMs do pair with a generative image AI model to provide these services behind the scenes, such as DALL-E 3 used by ChatGPT. There's a piece of CAD software called OpenSCAD which has been around for years and is particularly popular in designing parametric models where specific sizes and shapes can be easily adjusted to make the model fit a specific use case. With OpenSCAD, rather than designing your model by manipulating shapes in a graphical interface, you write a script to determine what shapes you want, what their sizes should be, where they should be placed and how they should interact, and then it will create what you've scripted. And so I wondered what would happen if I asked an LLM to write a script which would design a 3D model and then ran that in OpenSCAD. As LLMs tackle coding problems in slightly different ways, I thought I would test this with three different ones: ChatGPT by OpenAI, Claude by Anthropic, and Microsoft's Copilot, previously called Bing Chat. First up, we've got ChatGPT, and as I'm using free versions of all of these, this is ChatGPT 3.5. I want to request something fairly straightforward for now with simple geometry, so let's ask ChatGPT to write me a script for use in OpenSCAD that designs a space rocket. As you can see, it's now writing the code out for me, and then down at the bottom it's included a short description of what it's produced. This script creates a simple rocket with a cylindrical body and a conical nose cone, along with 3 fins evenly spaced around the body. Evidently, it has a good understanding of the core components that make up a rocket ship's shape, and it's nice to see that it's made the dimensions of each component variables, so without delving into the code, you can just change the numbers at the top here to change the size of each of these components. Now let's get this code copied and we'll see what OpenSCAD makes of it. So here in OpenSCAD we have our graphical view in the middle here, and to the left we have our script box. If I just paste the code that ChatGPT generated for us in here, I can then hit this button and it will run the script for me. Well, we certainly have our fuselage and what looks to be 3 fins featuring more detail than I was expecting, but just floating in mid-air, and that's it. Down here in the console you can see that a warning has been highlighted. This is because it's requested to make a cone in the script, but to create a cone in OpenSCAD you need to request a cylinder, then manipulate it into a cone. So let's get that changed and run the code again. Well, the error disappeared, so the code should have all run, but we still haven't got a nose cone. It looks like the cone has been subtracted from the bottom of the fuselage to create an exhaust rather than becoming a nose cone. Well, that didn't go particularly well, so let's now see how Microsoft's Copilot does with the same request. It's done similar to ChatGPT, generating the code and following up with a simple description. Let's copy the code and see how this fares. Well, that's definitely worse than ChatGPT and seems to have only produced a column. It's obviously prompting other objects in the code, so my assumption is, without analyzing the code, that it's just positioning all of the other shapes inside each other. Okay, well, third time's a charm, so let's see how Claude does at making a space rocket. Well, the first thing I'd note here is that it's written far less code than either of the other two, whilst the description text is probably twice as long. Let's see if this generates anything for us. Get this copied in here, and whoa, well, that's still unusable, but it's considerably better than either of the others. We have a fuselage, 4 fins, and a launch pad, all positioned in the correct places. And you can see that Claude has done the same thing as ChatGPT and requested a cone rather than a cylinder. Let's get that changed up and see if it does anything. Not only did it generate a nose cone, but it actually placed it in the correct place. Well, none of those went well, although Claude did evidently have a better understanding of where the shapes should be positioned at least. Let's give these LLMs one more chance, using something they should have more training data on, and should hopefully be using simpler shapes. We'll start with ChatGPT again, and this time we're going to ask it to write me a script for use in OpenSCAD that designs a chair. We'll grab this code and paste it into OpenSCAD. Well, I guess technically all the components are there, but again, its positioning is all off. Alright, well, let's try Copilot. We'll paste it in here, click run, and okay, that's not gone great. I thought it had nailed it for a second, but obviously that is very much not a chair. Okay, well, last chance for this LLM OpenSCAD pairing. Let's see how the winner of the rocket round, Claude, deals with a chair. Oof, yeah, I feel it still did better than the other two, but not by much. Though I guess if you turn that upside down, you basically have a stool that I'd happily sit on. Well, even with Claude's better sense of spatial awareness, and even if you had a good understanding of how to script in OpenSCAD so you could make tweaks yourself, this is clearly not the cutting-edge method of producing brilliant designs for 3D printing that we're after. LLMs and OpenSCAD are both fantastic in their own right, but for now at least, this pairing is not a 3D revolution. Luckily, there have been much more exciting innovations in this area, and this next tool that we're looking at is much closer to what we're after. Meshy.ai has a range of tools, but the specific one we're looking at right now is Text to 3D. This allows you to enter a simple text prompt, much like you'd use in an AI image generator such as Midjourney, Dolly 3 or Ideogram, and it will then generate a 3D model based on your request. Meshy.ai currently offers you 200 free credits, which allows you to generate and enhance roughly 8 designs, and then if you wanted to continue using it, you can purchase additional credits. Once logged in, we want to go to Text to 3D on the left-hand side. Currently, you can select between whether you're using the alpha or beta model, and for now, I'm running it in beta, so click Text to 3D and we're brought to the generation page. In the prompt box at the top left here, you can simply type out what you'd like Meshy to generate. So let's request a rocket again, and we'll see how it compares to one from an LLM and OpenSCAD. Once you're happy with your prompt, you can also enter a negative prompt if there are things that you explicitly want it to avoid including. I won't bother with this here, but it's a useful feature to have. Below that, you can choose an art style. You can set whether you'd like the design it generates to be realistic, cartoonesque, low poly, or leave it to automatically decide which style is most appropriate for the prompt. The last option you have is regarding the seed. A seed is basically just a big number. Because true randomization in software isn't possible, a seed number is used and all calculations are worked around that number to create a unique outcome. By default, you'll always get a randomly generated seed here, but you can opt to use a fixed seed if you wanted to run the same prompt again, making slight changes but getting a similar outcome. For our purposes here, we don't need to do this, so I'll leave this unticked and hit generate down at the bottom. Generating from a prompt costs 5 credits, and the time it takes tends to vary depending on how busy their server is at the time. I've had it take around 1 minute before, and also had it take around 20 minutes other times, so it really can vary. Once it's finished processing, it will give you 4 different draft designs. You can select each of these drafts to look over it in more detail. Once you've found a draft you like, you can hit the cog symbol next to it, and you can then select the texture richness.
As we are going to be 3D printing the model, we don't need the texture, so we can just select none and then hit refine. This will now refine the draft you selected into a better designed final model. This process can take a bit longer than it took to create the original draft, but usually within 5 to 15 minutes in my experience. Once the process is finished, the refined version will appear in the refined section. If you hover over it and click preview, it'll open up in the 3D view and you can now see it's a much smoother design than the draft. You can then click the arrow button here, select your desired format. For most people here, they'll likely want STL, and then you can download it.
Clearly, Meshy has produced a much better rocket than any of the LLMs, so let's request something a little more unique and even functional. And we'll throw in something that we all know that AI can find a little challenging.
Let's prompt a mobile phone stand shaped like a human hand. We'll switch the art style to realistic and hit generate. And it's given me 4 new drafts to look over. This one looks quite good. I was more thinking with my prompt that the whole thing would be a hand holding the phone, but this also works, and you can see the 2 prongs at the front for propping up the base of the phone. This one seems to have more completely ignored the human hand element entirely, but is more of a standard phone stand. This one, more than any of these, has fallen into our trap of human hands and AI's inability to fully understand them. And then finally there's this one, which is similar to the first and arguably has a nicer hand design, but is missing one of the prongs at the front to hold the phone up. Of the 4, I think I like this one the best. Yes, it's only got 4 fingers, but hey, if I 3D print this, technically it'll be more real than The Simpsons, and they've only got 4 fingers, and also has both of the prongs at the front. So let's get this one refined. Obviously I sped that up, but for reference, that refinement took pretty much 6 minutes to the second. Now let's have a look at it. I quite like this design. The base is a bit funky and we may need to do something about that, but this looks like it'll be a good functional phone stand, so let's get the STL downloaded. As I import it, you can see it's been scaled particularly small, which makes sense as I never gave Meshy a reference of scale. So let's get this scaled up. Now my phone is around 80mm wide, so I want these prongs at the front to be a little smaller than that to ensure that my phone fits. Let's select the scale tool and, keeping it set to uniform scale, change the Y dimensions to 65mm. Well, that looks great. Now to fix this bumpy uneven base, we'll just use the cut tool. I'll drag this down to a height that looks good to be the base of the stand, and then you can see here at the back there's a bit of a dip, so I'll drop this plane so it doesn't cut through that. I'll untick object B as we don't want to keep the lower half after this cut, and then click Perform Cut. I'm happy with this, so let's hit print and see how it comes out.
Well, I'm pretty happy how this came out, and it's actually blowing my mind a bit. This entire thing was designed by AI, which is amazing, but what's more is it actually works. Not only does it fit my phone perfectly, which I know is helped by my scaling it in the slicer, but the design is even holding it at a good and suitable angle for a phone stand. The bottom prongs ensure the phone isn't going to slip or fall, but aren't covering up the screen, and the whole stand is solid and stable and isn't just going to tip over under the weight of the phone. Meshy.ai is currently primarily focused on producing designs for use as digital assets, with a big focus on textures and less so on real-world applications. However, they're definitely aware of its potential for use in 3D printing, and I've no doubt that we'll see this area of their service develop very quickly. Another text-to-3D AI platform is Tripo, available at tripo3d.ai.
It offers a free plan of 600 credits a month, and then you can either top up the credits pay-as-you-go style at 1 cent each, or you can subscribe to a premium plan for a bigger monthly allowance. With Tripo, there are less features for you to choose from, and it pretty much gives you a prompt box. There is an image upload feature here, which I won't go into today with Tripo, but we'll be looking at a similar feature on another platform later on in this video. For now, we can just start typing. As I type, you can see the objects on display update to match what I've typed in real time. These aren't being generated live based on my prompt, but are objects that other users have generated previously with similar words in their prompts. Once you hit create, it will then generate a new model based on your prompt. As with Meshy, Tripo gives you 4 designs to choose from, and you can then hit Refine to create a better quality one. Let's skip past this progress bar. Now this rocket looks really impressive. Once you're happy with it, you can then select STL as the format down at the bottom and then hit download. This will then generate the STL mesh and takes 30 seconds to a few minutes.
That rocket is really impressive, and I'm particularly impressed with the level of detail that Tripo included in the mesh of the smoke around the base. However, I then decided to try and get it to generate a phone stand similar to what I made with Meshy.
However, it just kept insisting on including a phone in the model, no matter what I used in the prompt. I then tried prompting for a bowl shaped like a human hand, and it just gave me bowls with hands sticking out the middle. So Tripo seems to struggle understanding if 2 different objects are mentioned in the same prompt. However, looking at the models on their dashboard, Tripo seems to be very focused on character models and doesn't seem to have an issue generating known figures. So I thought I'd see how it would cope with the request Iron Man in the lotus position. It actually came out pretty well, with the exception of having an extra foot coming out his backside and another one in the middle of his ankles. However, when I exported the STL and imported it into a slicer, it becomes evident of how much of this detail was completely reliant on the texture rather than being physically modelled in the mesh.
Tripo is obviously a really powerful tool and definitely worth going and playing around with. However, even though the rocket it produced was really impressive, it doesn't seem to have the best grasp of the human language, which can affect how it interprets your prompts. This is why I really struggled to get it to produce a phone stand for me that didn't include a phone in the model. LumaLabs, also known as Luma AI, offers a similar text-to-3D service as Tripo, with similar results in terms of quality and prompt accuracy, though it does seem to be far quicker at generating and upscaling designs. However, it also has another impressive tool in its arsenal. Not only can it generate 3D models from scratch using text to 3D, it can also convert a video to a 3D model using a NRF, or Neural Radiance Field. Sort of similar to photogrammetry, where you take photos of an object from every angle and run it through an algorithm which then finds matching points from different photos and creates a point cloud. With a NRF, you record a video of an object.
You want to record 3 to 4 loops around your object, adjusting the height and angle of the camera on each rotation to make sure that you've looked at every side of your object from every angle. With LumaLabs, you can either download their app available on Android or iOS, or you can upload your video directly to their website at lumalabs.ai. Here you can see LumaLabs is training their neural network on the contents of the video so it can then reconstruct the contents in 3D. It can take up to half an hour to process, and once it has, you can then view it directly on the app or on the website. When you load it, it does this cool transition moving from a point cloud to texturing the object and then finally texturing the environment. You can then move around and view the model from every angle, zooming in and out and clicking on different points in 3D space to change the point that your camera rotates around. If you click up here, it will give you a range of different download options. You can download it as an object, of which you can choose from 3 different file formats. You can download it as a scene, either as a point cloud or full mesh, or you can download it as a 360-degree image. Those last 2 are more for if you've used it to scan a room or environment rather than an object, and for us with 3D printing, you're most likely going to want to download it as an OBJ. So with that downloaded, let's take a look at it in a slicer. Well, obviously it's still including the pole I had it mounted on, but that's easy enough to remove right inside the slicer. We'll use the cut tool to cut most of it off, but there's still a bit sticking out the bottom of the neck, looking a bit like the stub of a spine. To get rid of that, we can just add a part, we'll add a cube, and then we'll move, scale and rotate it until it's covering up the part we want to remove. Then we can use the Mesh Boolean tool, use the difference mode, select the head and the cube, confirm, and it's removed the extension at the bottom of the head. If you'd like to learn more about the Mesh Boolean tool, I've already released a tutorial on it on my channel. Now obviously there's very little flat surface at the bottom of this model and a ton of overhangs, but if we just slap some tree support material, that should be enough to handle it pretty well. And after a quick session with the paint tool, let's get this sent to print.
Well, that's pretty incredible. It's obviously not perfect and it's far from being millimeter accurate, but it seems a remarkable option if you just wanted to quickly make a fairly good aesthetic copy of something without being a 3D designer or having a 3D scanner. Now, the concept of uploading a video and converting into a 3D model may sound quite similar to the MakerLab AI Scanner, which I covered in a video a few weeks ago, and the performance of that was, to put it mildly, appalling. But I thought I'd give it another try, so I recorded another video of this same subject with the same lighting and in the same conditions as when I recorded the video for this one. So let's see how it dealt with that.
Once recorded, I uploaded the video, and after a while it highlighted the subject it thinks I want to scan. That looks good to me, so let's continue. The process of this took a good hour or so, but let's see how it came out. Well, the preview isn't filling me with confidence, but let's get it downloaded and have a proper look. Wow, it's quite remarkable that both this and the LumaLabs one were both produced from effectively the same video. This is obviously completely unusable, but it is, to be fair, listed as an experimental feature, and I've no doubt it will be improved soon.
LumaLabs video to 3D is fantastic if you've got access to the thing that you want a model of. But what if you've just seen something online, or you grabbed a photo on your phone but you're not able to go walking around it taking a video? InstantMesh, hosted on the AI Superhub Hugging Face, allows you to upload a single 2D image and convert that into a 3D model. Now, you could go completely AI generated and use something like Midjourney to create the initial image for this, but for this example I'm going to use an actual photo.
InstantMesh is currently completely free to use, and I'll make sure to include a link to all of these tools in the video description. Let's have a go at running a photo of the recently retired Atlas HD humanoid robot from Boston Dynamics. If the image is like this and has a detailed background, you can tick Remove Background, and when you click Generate, it will then try to determine what the subject is in the image and remove the background. You can see here it's done an okay job, but it's failed to remove some background areas which could affect how the model ends up coming out. Once it's isolated the subject, it then immediately begins processing it, and will then create a number of images of that object showing how it thinks it looks from different angles. It then uses these multi-view images to generate a 3D model, which you can then look at here. If you like the model, you can then download it either as an OBJ or as a GLB. As with the designs we looked at earlier, there's no reference of scale for the object generation, so we need to scale this to what we want, and we'll get it standing upright. Well, the general shape is there, but there's a lot of issues with this design, not helped by the fact it didn't properly remove the background. Let's try another photo of Atlas HD, this time one that is already on a perfectly white background. As there is no background to remove, we can untick Remove Background and then just hit Generate. Okay, well, the multi-views are looking pretty good. Fingers crossed for the model. Oh, the model looks a bit cleaner, but the wires and cables are broken and look messy. Let's download it and see how this looks. The general shape of this does look better than when we had the background auto removed, but there's some funkiness going on with one of the arms, and the cables are all broken. Let's try one last image. We'll use Boston Dynamics' other lovable dancing robot, Spot. There is a background to this one, but it's very simple. Also, there's no wires or cables to worry about, so let's see how it does. Well, it's removed the background without any issue, so that's good, and the multi-view images look impressively accurate. Okay, well, the texture looks pretty messy, but the mesh, which is what we care about for 3D printing, looks fairly good. Let's get this imported into a slicer. Well, there's obviously some inaccuracies, such as the middle hinge of the arm, and it's all a bit wobbly, there's no straight lines, but that can kind of be expected when it's coming from a photo. It's impressive that it does have all 4 feet starting at the exact same layer, so it's not made one leg slightly longer than the others. However, for printing, it'd be nice to have a slightly larger footprint, so I may cut the very bottom of these feet off. Let's give it a quick paint job and see how it looks.
I actually really love this little guy. No, he's not perfect. No, he's not going to win any design awards. And yes, there's lots of problem areas and inaccuracies. But it's more than good enough for a kid's toy or a model to represent the robot sat on a windowsill or a desk. What really blows my mind is that there was absolutely no design work at all from my part in producing and printing this thing which I now hold in my hands. Yes, the horse's head had a lot more detail and a lot more accuracy than this, but that makes sense because of the amount of information it had to go on. But this was literally produced using a single 2D image. And that phone stand earlier was produced with nothing more than a text prompt. These are just a handful of the AI tools currently available to use for free, which can be used to generate models for 3D printing. Whilst some of them do allow you to download the models as STLs and OBJs, with the exception of the MakerLab AI Scanner, which currently doesn't work, none of them are designed specifically with 3D printing in mind, taking into account things like minimizing overhangs. As a result, even when you do find a model that you like, you may need to make some simple tweaks to it in the slicer like I did with these. As these tools develop, it would be great to be able to add things to the prompts such as tolerances and sizes for dimensional accuracy, as well as it having a better understanding of rigid design for smoother, less bumpy surfaces. Even in their current state, not only are these tools fun to play with, but in the right conditions they can be genuinely useful. As I mentioned earlier, I'll pop a link to all the tools that I've covered here in the video description. If there's a tool that I've covered here that you'd like a more in-depth tutorial on, or if there's an AI tool that you think is great for 3D printing which I've not covered, make sure you let me know in the comments below and I can cover them in a future video. If you found this video useful and you've learned something new, please make sure you hit the like button, and while you're down there, hit subscribe to make sure you get more 3D Rev goodness in your feed in the future. As always, thanks very much everyone, and until next time, happy printing.
I'm genuinely really impressed with the quality and performance of some of these tools, and I'll continue to cover more AI 3D printing tools in the future. I've also got a mini-series on different methods of 3D scanning coming very soon.
Thanks very much for sticking around. If you'd like to support me and my channel and get yourself a load of bonus 3D Revolution goodies, you can now become a channel member by hitting the join button below my video and becoming a 3D revolutionary like these fantastic people below. If not, why not check out one of my other videos, learn something new, or just have some fun. Either way, thanks very much everyone, and until next time, happy printing.